Fresh water is Earth's most precious resource. Living things not only need it to survive, but also to grow. And while we humans think of water as something we need to drink, it is also needed to grow all of our food. As technology continues to advance, a new technique for bringing fresh water to Earth's ecosystems and agriculture is called cloud seeding. Cloud seeding is a weather modification technique aimed at increasing precipitation. This is done by dispersing different substances into the atmosphere that act as condensation nuclei. Common substances used for cloud seeding include silver iodide, potassium iodide, and sodium chloride. And there are many ways that these chemicals can be dispersed into the air, which we will go into later. But how is that possible, really? How can you release something into the air that isn't water and get water to condense into rain? We can answer that by first learning how clouds form. In short, the warm air of Earth's surface rises into cooler air in the atmosphere. When the warm air reaches the dew point, which is the point in the atmosphere in which the water vapor condenses into water, it begins to form clouds. The key point is that clouds are not able to form unless the water vapor in the air is able to condense. And much like the way water condenses around a cold can of soda, water in the air condenses around tiny particulates in the atmosphere like dust or pollen. So when cloud seeding operations release tiny particulates into the atmosphere, it encourages the condensation of water into clouds, which then grow into systems capable of producing rain. But how are these chemicals actually dispersed? What technology is actually used to do this? Let's ask Supertutor to explain the technology of cloud seeding. So there are two main methods for releasing particulates into the atmosphere. The first is aerial dispersal. In the case of silver iodide and potassium iodide, aircraft equipped with flares or burners release these particles directly into the target clouds. The flares are ignited, producing a stream of particles the aircraft distributes as it flies through the cloud. For sodium chloride, aircraft can also disperse fine salt particles using ejectable canisters or other dispersal mechanisms. An aircraft can be equipped with spray systems to release water solutions containing seeding agents like sodium chloride. This method is typically used to enhance the hygroscopic properties of clouds, prompting the formation of larger water droplets. The second method is through ground-based dispersal. So instead of having a flare or a burner attached to a plane, you simply put it on the ground and release these chemicals into the air from the ground. The generated particles from these burners are carried upwards through winds and updrafts. And this is interesting. Specialized cannons or launchers can shoot capsules or shells containing seeding agents into the atmosphere. These capsules burst at predetermined altitudes, releasing the particulates. That sounds cool. That sounds amazing, interesting, cool. Now I think it's important to know why they actually use these specific chemicals, and that's because potassium iodide and silver iodide have a crystalline structure that mimics the structure of ice crystals. And sodium chloride, table salt, is hygroscopic, which means it attracts water, and in the case of cloud formation, enhances condensation. And weather radar and satellites will be used to monitor cloud formation and precipitation, while rain gauges on the surface can be used to track the actual amount of rainfall. Cloud seeding has the ability to increase the output of agriculture in arid locations, boost water levels in rivers and reservoirs, and actually reduce the intensity of storms because the moisture in the air will be used up to create the rainfall. However, due to the extreme cost and some environmental concerns, cloud seeding has not yet blossomed into the revolutionary technology it can be. Whether or not changing the weather is ethical, and whether or not it can produce predictable results has yet to be determined. Hopefully this video quelled your interest in cloud seeding and maybe taught you something new. If you're at all interested in learning more and having a personal superhero on your side, go ahead and use the link in the description and use code AIDEN to try for yourself 7 days free. That's again code AIDEN for 7 days free. Thank you for watching, and allow me to take you away with a rhyme. To make it rain when the sky is parched, or hailstones small so crops aren't starched, cloud seeding comes to play its part, a weather change science art. Seeding agents, they make stands, silver iodide, potassium in our hand, propelled the sky and clouds unfurl around them, water droplets twirl. On aircraft wings they soar and glide, in cloud-swept heights they abide, from ground stations they ascend, by air currents upward send. And rockets burst so artilleries ring, seeding particles take wing. In cloud systems they thus combine, a weather shift by design. Yet every coin has two sides, and cloud seeding too divides. Yes, it brings the needed rain, but long-term impacts remain. Does silver iodide harm our soil? Does tampered weather bring turmoil? Costs also loom and questions rise. Are benefits worth the price? So tread with care in cloud seeding's course. Weigh the gains, but also the remorse. Weather's gifts, nature's voice. In the end, make the wise choice. Subscribe to Supertutor, and we'll see you in the next learning adventure.
Supertutor, teach me right.